Welcome back, Physical Science 20. So we'll look at this last example here, then we'll add another example in. Block of iron. Okay, iron starts off at a temperature of 20 degrees C, and it's heated up, so it's absorbing heat. Oh, I forgot to do one little thing in this other one. If we go back to the previous example, for some reason I lost the negative here. So let's go back, fix that up. So negative. And negative sense releasing energy. There we go. So please make that fix from the previous question. Negative. This one though, we're iron, heating it up because it's placed in boiling water. The quantity of thermal energy for this temperature change. Again, for some reason, I'm not sure why this turned out like this. Formatting issue. 4.9 times 10 to the 5 joules. There we go. Calculate the mass. The quantity of thermal energy. That's big Q, so we're actually given the value of big Q. So be careful. If you see a result here with joules, that is what Q is. 4.91 times 10 to the 5 joules. And we're looking for mass. Initial temperature started off at, let's see here, so let's make this Ti. Started off at 20 degrees C, 22. T final, it went up to 100. Delta T, TF minus Ti. So it's going to give us 100 minus 22 to give us 78 degrees C. C, the specific heat value of iron. Let's see, we don't have it there, but hopefully it's on this chart. There it is right there, 4.5 times 10 to the 2. 4.5 times 10 to the 2 joules per kilogram degrees C. And M is what we're looking for, of course. So MC delta T, 4.91 times 10 to the 5 is equal to mass times specific heat times 78. Okay, so I can multiply that part together. When I do that, I get 35,100. Okay, just to solve for M, it's M multiplied by 35,100, so divided by 35,100. M equals 13.9886 kilograms. If I look over here, I have 3 sig figs, so I'm going to round this off to 3 sig figs. That's an 8, so that gets bumped up by 1 unit, so that's going to be 14.0 kgs. All right. So there we have that last example. Now I'm not going to go to the next section yet. This is kind of part 1, but I do want to add a question in here. So if we could turn back a page, I'll show you where to add it in. So if you could turn back to where we have the specific heat capacity table and go to the very bottom, there's a little bit of room there. I want to add one little question there. So write small if you could. And we'll call this example 5-gram piece of aluminum, or as the Brits say, aluminium, at 20 degrees C is heated up with 138 joules of thermal energy. Determine the final temperature. Okay, squeeze that in there if you could. Okay, let's see what we know here. We know the mass is 5 Gs. We know it's aluminum. So if we look here, aluminum, 9.2 times 10 to the 2. 9.2 times 10 to the 2. Handy dandy liquid paper. 9.2 times 10 to the 2. All right, we also know TEI is 20 degrees C. And let's see, what else do we know here? MC, so T, and then Q. Thermal energy is 138. And TF is what we're looking for. All right, so Q equals MC delta T. So we have 138 kilojoules being transferred. 5 Gs, now again here, to change that into kilograms, you divide by 1,000, right? So move the decimal 3 places to the left. Okay, so 0.00500. C, 9.2 times 10 to the 2. Now, delta T can be represented as TF minus T initial, as we looked at it earlier. And of course, we know what TI is, right? We know that TI is 20. So TF minus TI. So what I can do here is multiply this out first. When I do that, I'm going to get 4.6. Okay. Now I want to get isolate TF, but before I can do that, I need to isolate TF minus 20 first of all. So it's multiplied by 4.6. So divided by 4.6. And let's see here, I get, I get 30. 138 divided by 4.6 is 30. Then add 20, no, so it's TF minus 20. So to isolate TF, you had to add 20. Add 20, and TF works out to be 50 degrees C. So it gives you an idea of how you rearrange that equation to solve for TF. Okay, so that's kind of the end of part 1 of the video. So you should be able to do questions 1 to 5 now on the assignment. And then the remaining part of the assignment we'll do at the next video. So questions 1 to 5 in the HT 1.3 assignment. All right, we'll see you again.